1, 2, 3. Do you hear me well? Okay.
Yes.
I will take just 5 minutes to present Women Who Code, especially Women Who Code London, for everyone who didn't yet see in this presentation, haven't seen yet. So, Women Who Code, the goal of Women Who Code, to empower diverse women to excel in tech industry. Our vision tech industry where diverse women and historically excluded people thrive at every level in the industry. Our values focus on the mission, design for inclusion, advocate for change, and journey forward. And overall, Women Who Code right now is 43,000 members all over the world and represented in 147 countries, which is quite impressive. And Women Who Code London is quite a big network. We actually connect people not only from London, we have volunteers from Amsterdam, from Turkey, from Spain, Valencia. And we have code of conduct. In 2 words, please be nice to each other. If you see that something went wrong, please do not hesitate to contact with us. Actually, what's on? It's like a little bit about Women Who Code. Okay, that's being decided to hit the atmosphere. Okay, so if you haven't heard about Women Who Code, we actually do tech talks, a lot of tech talks. So, for example, Apache Kafka, it's backend tech talk, but we talk about everything: data science, data analytics, front end, etc. If you'd like to grow up as a speaker, you also can apply, and we will host a talk with you. It could be even small thing like your favorite GitHub for cuts, but actually, if you'd like to train your speaking skills as well, we're also here to support you. And yeah, we also have a lot of interesting dive in deep tech talks like Apache Kafka, for example. We have mentorship program that's right now 4th season that actually have their own website, and you also can search right now for ad hoc sessions. But do not miss the next mentorship program that's for long term, matching for mentors and mentees. And yeah, that's incredible. We have almost 50 mentors right now and 50 mentees. So 100 people participate right now in our mentorship program. And right now we started our ad hoc sessions. So you can find a mentor for like session just ad hoc. And we already have 7 people who going through this process. And we have every month book club, and we have their books like leadership skills. Like previous one was actually Atomic Habits. That's about how to actually balance between work and life and have a good habit that can help you to recharge, to repair, and maintain everything that you want in your life. And we combine them with technical books as well. So yeah, please join us. Today we running our machine learning competition, and I hope it will be a very cool journey for you, and you will learn a lot from this machine learning competition. And also, previous year we did mock interviews to support women to enter tech industry with different interviews, like behavioral interview and coding interview. And I hope we will do another one this summer. And if you'd like to help us, please join us as volunteer. So organize this interview is also like to find people, to match them each other, and etc. So yeah, if you'd like to help and participate, please join us. Yeah, and yeah, we are looking for leads for tracks. We are looking for people who can help us with social media recognition. So on this picture, you see Ayla from Turkey. She joined us just through meetings, and she started to advocate a lot in Twitter. In LinkedIn, she helped us, and we also have Instagram. So if you'd like to help us to spread the word about Women Who Code, you are very welcome to volunteer. And we need coordinators during in-person events like this. But we will do much more this year. I hope that we will do maybe even each month. So that will be cool. And we need volunteers to help us as well. So yeah, please join us. And that's it what I wanted to say. Thank you so much for your attention. And I give my not imaginary finally microphone to Yin.
Thank you, Silke. I'm going to transfer the this.
Sorry, there's a question.
Yes.
So can you please share the mentorship program and other links that is being mentioned?
Sorry, can you repeat that?
The mentorship program, link for a mentorship program.
Oh, the link for mentorship.
Yes.
Yeah, I will share links to actually Linktree that has a lot of links. And for mentorship, okay. Yeah, let me share one more link for you.
Thanks.
Thank you. All right. So this is going to be a 6-week session for machine learning competition. And the target audience would be a total beginner to machine learning. However, we do require to have a basic knowledge of Python because teaching Python is one step and teaching machine learning on top of Python is going to be another step. So we do require everyone to have a little bit knowledge about coding. Because I code in Python, so I expect I can answer your question about Python. If you're coding in other language, there is not much I can help with. So yeah. I hope you all have access to the Wi-Fi yet. The Wi-Fi is NU Wave dash guest, and also I post this link on the slide right now, but I'm going to show the link afterwards as well. So the bright yellow link is for a Kaku competition. First, I want to introduce myself. I had a PhD in physics, and I've been a research associate on machine learning for 2 years. Currently, I'm working as the AI R&D lead in a company called TG0. It's a startup. I'm also a member of Institute of Math Application. I would say I have roughly basic knowledge about what machine learning and the algorithm behind it, mainly focusing on mathematics of the machine learning part.
This meeting is being recorded.
Yeah, we know about that already. No worries. So yes, yeah, where was I? Yes, so I have a basic knowledge about the math behind machine learning. I know a bit of machine learning engineering because I've been doing that. I've been constructing the machine learning architecture basically for a few years. On top of that, I know a little bit about the big data, how to sort out the big data with machine learning. But if you want to ask me about basically the machine learning ops, there's very limited knowledge for me to actually know about that. So that is associated. If you want to go to Google to get involved in a machine learning architecture or machine learning operation, I don't know much about it. So yeah, great, because we are all beginners, so it's quite comforting for me because you won't ask me about anything about machine learning operation. That's good for me. And then I'm going to introduce you to Silke. You probably have met her like downstairs already. Silke is also machine learning lead within WWCode. She's going to assist me and helping me on answering your questions. So should I give you a little bit minutes to introduce yourself? I know it's a sudden request.
Do I have to stand somewhere?
Well, it's up to you. Like,
okay.
Well, it's okay. I don't think you can see you from the camera.
That's what I was wondering. Yeah.
The camera is here focusing on this side.
Anyways, yeah. So I've got an MSci in mathematics from Payroll College, which is fairly recent. So I graduated in 2021, and then since then I've actually changed my job recently. But I'm now working as a data scientist, and I helped Ying with the last competition that we hosted. And since then, I've become a machine learning lead. So, yeah, excited to be more a part of Women Who Code. And I also put in here, one of my hobbies is language learning. So I do know, of course, Python, R, MATLAB, SQL. But I also really like learning languages. So English, French, German, Spanish, and Romanian. is another hobby of mine.
Thank you, Silke. Okay, now I'm also going to introduce you to Eka. Eka is not in UK, so she's currently helping us to coordinate all the questions online. So if there are some questions popping up in Zoom, and please post that on the chat box. Eka will basically remind us, having their microphone up and. Well, maybe not their microphone up. Like basically, Eka will talk to us straight away. We can hear her, and speak out all the questions, so we can answer them. We can answer them here as well. And Eka, would you like to introduce yourself a little bit as well?
Okay. Yes, please. So I'm Eka. No, Eka is short name. I'm Ekaterine Pashkareli. I'm from Georgia. And I graduated from the UK university, from University of East Anglia. I did masters in development economics. In Georgia, at this moment I work for the university as a data analyst. But my previous job was related to data science because I worked for microfinance organizations, and I built for them credit risk scoring model using Python. And so last year I joined to Women Who Code, and I'm happy to be part of this society. And I participate in one of the competitions with Silke as well, and in this group, and it was a really great pleasure for me. And I'm looking forward to do this one more competition as well. And wish you all of you success. And yes, please enjoy. It would be a really good and enjoyable journey, I'm sure. Thank you.
Thank you, Eka. Yes, Eka was in the 2022 machine learning competition as well. Last year, we hosted online in about November to December. And at the time, we still have a little bit prize at the end for the winner. We got waiting for the T-shirt, which are supposed to be printed out very soon. So, but hopefully this year, let's see what we can get for a prize. So we don't know what we can get, maybe just applause in the end. But yeah, we'll just enjoy the process. So yes, what do we do in this event actually? So what I'm going to give is a brief introduction to guide you in your machine learning project. I might do a little bit teaching of what kind of algorithm will be the best, or something about the algorithm, but I won't teach that much. We have separate events to teach machine learning algorithms. But in this one, we are mainly going to do hands-on coding. So yeah, and to see how we actually start looking at the project, see what we can do with it, and how to construct the architecture, and how do we actually figure out the solution. Basically, it's problem-solving skills. And also, I will answer your technical questions. And me, Silke, and Eka will answer your technical questions, whether you encountered them here while you're coding, or you had them when you were back home and continue doing this competition. And also, the third thing we want to do is actually we can code together. Because as a person who have a full-time job, I understand how difficult it is to get some of my evening time to do something, motivate myself to learn some other skills, do some other things. So it's always a struggle for me. So I understand all that. In this case, that's why I want to have this in-person event. So we actually attend a nice venue. Thank you, James, for this lovely, beautiful room, I have to say. And we have the tower bridge. On that side, we have the Thames on the back. So it's a beautiful environment, and it's a great opportunity to have a little community. So we can start coding together. That's what motivates me, at least. So I want all of you to enjoy all that and enjoy coding together. And the plan is, we are going to have a session once per week for 6 weeks. And we are going to have, this is about half an hour for code feedback, depends on the time length. Every week, we are going to review a little bit of code from some of the volunteers. If you are happy to show us your code, maybe we can walk through it to see if there is anything we can improve on, and if any part of the code which is like inspiring or so good that we want to share with everyone. And also, we're going to have about 1 to 1.5 hours of coding together. If you have any technical questions, we can answer them on site. So basically, that's the plan of it. But I do need your help designing the whole sessions because I received the news that we cannot have in-person event more than twice per month. So I do see the struggling, and because in the first event we have about 30 people registering for this, but as we can see that probably like half turnouts, that's always expected. So I can also foresee that there will be dropouts along with the session, and I do not want to keep this whole venue or like, keep this venue and having like taking part of the occupation of the in-person events when we don't have enough attendees. So like afterwards when we have a discussion, maybe I could gather some ideas to see how many people would like to join in person every week. It's going to be every Thursday, 7:30 to 9 p.m. And so what should you do, I'll say? Allocate a time for this competition. 1.5 hours is not that much when dealing with coding, especially when we want to, in total, that's probably like 9 hours to solve a machine learning problem. I do not see that actually being achieved. I can simplify the questions, but still, if we're in a learning process, that's not enough. So do you allocate yourself a bit of time, maybe 1 hour on a Friday night, or maybe not Friday night, because that's a social night. So maybe 1 hour, like on a Sunday night before the work, or on Monday night. Give yourself, set up that time in your calendar to do coding, or even before, like Wednesday night before the the session when you get examined by everyone else. So yeah. And also, if you have any questions, ask them on our Slack channel. We have a machine learning channel on the WWCode Slack. If you are not within this Slack workspace, so this is WWCode.slack.com. Find our channel called machine_learning and ask your questions there, and it will we are monitoring the channel every now and then and answer your questions. So now let's talk about today's task. We are going to have a look of the competition, the description of the competition, and see what it is trying to do. The first thing to understand a problem is to read through the problem, understand what they are offering us, and then have a look of the data, because when it comes to a machine learning problem, actually as a person who actually go through the whole process, I understand like pre-processing the data takes, I'll say, like 90% of the time. Fortunately, the competition we chose is kind of clean. The data is not that messy, so it won't take up 90% of the time, but it probably take up 50% of time in the end. So we need to browse through the data together, and I'll tell you about how you can actually look at these data. And then we need to set up the coding environment. So as I have already mentioned, we are going to use Google Colab. If you have other things you're familiar with, feel free to use that. It's not a must. It's just because like Google Colab has a very consistent Python and also machine learning package installed already. So yeah, and we are going to prep a little bit for the data analysis. Yeah. So what we're going to do next week is that I'm going to separate the problems into smaller ones. So each one of you could choose a problem to solve. Basically, in this competition, there there are about 10 labels we're going to predict. And we're just going to choose, each one of you are going to choose only one of the labels. So we're not going to do a multi-classification. We're just going to do a binary classification. When dealing with binary classification, I would say it's slightly easier. And there are so many things we can choose from. And yeah, so then it's probably, if we actually manage to finish one, we can actually proceed from that and continue with multi-classification. And then, if you want your code to be assessed and have a look and talk about, and send me the notebook before Thursday, I say before Thursday night, maybe like before Wednesday night, so I have a little bit of time to look at it. And also we're going to do data analysis review, which is the code review in the beginning of each session. And today we spent about half an hour, like just giving you an introduction, but next week we're going to spend half an hour reviewing the codes. Then the problem we're choosing is actually from Kaku. What is a Kaku? Kaku is a kind of learning platform and also code sharing platform and also a competition platform. So it does so many things. I think as a company of Kaku actually expands, they do so much more things. So what they do is like some of the other companies, commercial companies, would post a question with a prize on top of it. And there will be like thousands of teams joining to trying to solve that problem. And whoever actually winning the, basically achieving the top rank will get that prize. So they're trying to recruit all the publics for a machine learning solution. And apart from the competition, they also offers a lot of tutorials to how to do the solve a machine learning problem. So actually, I learned a lot of my machine learning knowledge from this platform, which I find really useful. Okay, now this is the link for the Kaku competition. If you haven't registered with Kaku, please take your just register with it right now. And this link will go to a Santander recommendation system that basically the problem we're going to solve in the 6 sessions. And I'm going to see, I'm going to have a look of the chat to see if anyone had problems seeing the Kaku. Okay, the link should lead you to this page. Santander product recommendation. So in this page, we can see a few sessions, like there is an overview of what kind of problem they're trying to solve. And also on the data side, it gives you a description of what type of data it has. You can see here, there are 3 files, trend file, test file, and sample submission. So what it is doing that, we are using the trend.csv file to train our machine learning model, and we're going to predict the result using the test CSV file, and then they give us a template format of sample submission. So basically you submit your result in this format. So that's the 3 files, quite a straightforward one. Yeah, and that's it. If you want to see how others did it, there is a list of kind of code. So a lot of teams joined and wrote a description or wrote a code. Basically, the process with how they solve this. And online, and there is a discussion session. So this is a very old problem, so there's no way we can win the prize for sure. So, but it's still fun to actually look at what others discussed, because it's a very old problem, which means almost every questions, every problem has been discussed in the discussion. And yes, and you can see the leaderboard over here. So, like, we can see a lot of people, like the highest score is 0.03 and entry is 85, which means they tested 85 times from using the test result. That is actually quite a high number, because if you keep testing your score, like it's eventually what it does is the machine learning model will start to memorize your test set, and the result is not actually accurate unless they have a hidden test set. The company didn't tell us about. They were tested with a hidden test set. And that's how it works. So first of all, I want everyone to download this data. So when you, on the right side, you see this download all button. Download this data set, connect it to your maybe Google Drive or your local drive, as long as you can access them from your IDE. So there are a few things, like download them first. And also, please stop me if I'm going too fast. Maybe you are still downloading the data, but I have already gone through the data set. Let me know, stop me. First of all, the thing is, like, I tend to download all the data onto Google Drive, and then I connect the Google Drive with the Google Colab. So this is the code you need to use. From Google Colab, import drive, that's the package. And this line of drive.mount is basically mounting the Google Drive to the Google Colab platform, and then assign your path to where the data is. So for me, I'm assigning this path to direct me to where the data sits. And I have a trend file path, test file path, and sample file path. So that's basically the process to access to your data first. And then this training file is quite big. I do not know the Wi-Fi speed here, but because it's about 2.5 gigabyte, it might take you a while to download it. So we can work with test file as well first. And also because the trend file is about 2.5 gig, it will use up a lot of RAM, and Google Colab is not using your own RAM. It is using the cloud server RAM, which they don't give you much. So there will be a problem when you're dealing with the big data. Luckily, pandas have a method to separate files. So I generally using pandas when I want to do the data analysis. If you are trying to use neural nets with TensorFlow, TensorFlow also has another way to separate all the data into chunks, and then you can import them during training, bit by bit, basically. But in this case, we're not dealing with neural nets yet. Neural nets is sounds like a magic algorithm which solves everything. Unfortunately, it is computing like I would say, has a very high computing power. It takes a long time, and it takes a lot of computing resource. So it has its limitation. It also has its advantage. But machine learning is not just about neural nets. So in this case, I would like to have everyone try out on the other machine learning models, like decision tree, principal component analysis, or nearest neighbor, something like that, to deal with either a classification problem, which separates red from blue from green, or dealing with a regression problem. Regression problem is basically predicting a number, a numeric number, like, okay, this result is from 0 to 0.1 to 0.2 to 0.3. A continuous number, that is a regression problem. So, yeah. Has everyone downloaded the file? Okay. All right. And if you're trying to just separate some of the data, use the read CSV file with the chunk size and looping the chunk size, basically. I'm choosing the first chunk. Oh, sorry. No, I'm printing out the first data, actually. If you break after the first loop, basically your data frame is going to be the first chunk. And I'm printing it out to show what the column names are like. So this is what the data looks like. As we can see, for us, for me actually, this is not something I can work with yet in machine learning. In machine learning, we're talking about numeric methods, which means everything needs to be a number. Like no matter it's a date or it is a string, they all have to be numbers. So in this case, the first step is actually transform all these things into a number. But do we just transform them yet? No. So the thing is, we need to understand what they are. Do we actually need it? And also, as you can see, there is a lot of value as none. So there are loads of non values, which also means we need to understand what the other data looks like, and then we can deal with the non-data. Okay, now I'm going back to this, to the Kaku, to look at what the data looks like. If we read through the description, what it does is that it gives us a lot of information. They are under the column names. They give us lots of information about the gender, the spouse index, and the deceased index. They want us to predict whether what the customer or the customer would open up account. It can be current accounts or short-term deposits, long-term deposits, whether they will open up these accounts. So what we're expecting here, if we look back into, let me see if I can do this. So yes.
Can you scroll up and just show the code at the beginning again to connect to Google Drive?
The Google Drive one. Yes. I'll give you a quick glance about what the rest of it looks like. Everything starts from index EHOR to the end. They are in the value of 0 or 1. That means if it's 0, this person did not open account. And if it is 1, that means this person opened this account. And that's what it looks like. If you look at the test data set, you will realize all these columns are not offered. So this is what we're predicting. And as you can see, there are probably 20 accounts we need to predict. And that's going to be quite a problem for us yet. So now we have already understand there is an input and there is an output. So the input is probably 20 channels, like 20 features. We call it input is like 20 features, probably 20, and the output is 20. That is quite a big number. We're talking about like we're trying to generate all that is like if we're talking about 20 inputs to 20 outputs at the same time, that's quite difficult. Also, the first thing is like we need to see whether we can solve one problem first, like whether we can predict if this person is going to open a pension account. Then if we start to separate our problems into little ones, we can have a look of what the feature looks like now. There are so many things. Customer code, we do not need that because it just represents, okay, this is one customer. Like right now, we're trying to solve it, like using our own common knowledge, whether the custom code will be related to any of the account. It doesn't really relate it to that. Something like the employee index, customer country residence, customer sex, age. So first of all, we want to understand the data. What does the data mean? I'm making a few examples of it here. Like, from what I think, like, I want to know, okay, what is related to pension? I think maybe the age related to pension, if someone is like 30 years old, they probably didn't want to open up a pension account. If they're 50, they probably want to open a pension account, maybe, or maybe not. That's something I think which will be related. So I want to look at what the data looks like. What I did here is I list out all the age. The CSV file we extracted from it turns out like configured as an object, so I need to transfer it to integer first. However, I couldn't transfer it to integer. In the beginning, when I was testing this out, I want to make an example of what I think would do. So I tested it out and realized I cannot turn that into integer because there is a non-value in this. So what I did is I turned them into a string first, and then whichever value, and I listed out all the unique values in the age column. I think about 10,000 or 100,000 row, 100,000 customers. And I realized, okay, what is going on? Why can't I turn this into an integer? Then I realized there is a NA somewhere here. So there's a non-value, which basically means that the bank doesn't know what the age of the customer. So I turn that into 0. In this case, well, age 0 should be reasonably understandable. And then I turn them into integer. Then I could do it successfully. So this is the pre-processing of a data set. And I'm just dealing with one column. And then I'm thinking, okay, I have already known the age, and I have a column to show that whether this person has opened up a pension account or not. I'm thinking about, okay, I want to do a box plot. That's what I'm saying. Visualization in data analysis is quite important because by just looking at the data, you won't understand what is happening. You want to see it. Okay. All right. Let's see if we can run it again. So there's a very sad face. At the same time, since I'm scrolling to the top, one of the very common visualization tool I'm using is Plotly. In Python, there are something else like PyPlot, which everyone use. And that is, if you want to do something more detailed, PyPlot is pretty good. But currently I'm doing Plotly, which I think is prettier. I am quite a visualized person, so let's see. Plotly, yes, but you can use any other tools you like. And if you want to make it prettier, Seaborn is also a pretty good package. So dealing with the data analysis, data visualization is kind of quite important. I'm currently using this book, Data Visualization, but you don't need a book. Basically, you can search online about what kind of plot is suitable, other things. So if you run out of ideas about what kind of plots you do need, because different plots would actually affect your, I would say, your way of looking at the data. So there are lots of box plot, scattering plot, or histogram, lots of things. Like think about what could work. Let's see. So in this case, what I'm thinking is like, I can check the relationship between the age and whether they open up a pension account, and also check whether they are new customer or not. So if they are so from what I think is like, if they are new customer, maybe they won't start a pension account immediately. They probably start with a current account. But you never know. Like you have all these, like you would have all these guests, and then test them out slowly. I think I opened up too much, too many data. Maybe 10,000 is too much over here. Oh, that's a million. I think probably. I'm going to leave the coding part to you right now while I sort out this thing. So I'm suspecting the problem comes from. Too much chunks, too much data in this chunk. I'm opening up a million rows, so maybe that's 1 GB. So the RAM cannot deal with that. Okay, I'm going to give you a little bit of time to start coding. Find something you think, okay, I want to look at a current account. I want to look at some like other account, like investment account. And I'm thinking, okay, maybe it's dealing with the income, because the bank does have a record of how much income per household. And maybe I want to check, maybe it's related to the age, and it's related to the gender, it's related to whether they are in the country or not. Maybe if they are foreigners, they would have either higher or lower income, and maybe they would either like foreigners probably prefer investment account, or maybe they don't prefer investment account. Everything need to be visualized. So find something you would like to check, and let's start coding. And if you have any technical questions, feel free to ask me straight away and or post it online. We also have drinks and lovely, I'll say nibbles offered by James, and we have a little bit cupcake and coffee and water at the back. Okay. I don't want to interrupt you guys yet, just since I have already managed to plot it. So I think like 1 million data is actually too much. So I reduced it to about 100,000, and that should give us enough data to have a look. This is pension account over here. And on the y-axis, that's age. And also different color means whether they are new customer or not. If it's 0, that means they are not a new customer. If it's 1, it means it's a new customer. So I'm doing a box plot. This is called a box plot. Over here, each dot is actually a sample. And the box plot is basically showing us the mean value and the variance of this data set. And yeah. So what we are looking at is we want to see if someone opens up a pension account. And as we can see from the first 100,000 values, none of the new customers actually open a pension account, which means we can basically say in the coding, we can say that if this person is a new customer, they would definitely not open a pension account. Well, maybe not definitely. Like, we still need to check the other answers. If we are plotting them in a loop, so you can like plot every 100,000 data set to see if it actually says something about it. So if they are a new customer, let's say if it is the whole data distribution, new customer doesn't actually open up a pension account. And also, this one shows up whoever opens up a pension account, their age is about 50. Minimum 20, maximum 70 to 80. Yeah, like they definitely need one. So we can see that, okay, the age does define how the pension, whether the pension account being opened or not. So it has a bit of impact. If this person is about 50 years old, it's more likely they will open up account. So that's the relationship we do find out. Age does matter, but new customer matters more. That's basically a decision point. And then I want to look at something about, okay, does the gender matters? Now I'm looking at the gender. Everything else is the same. The age is the same, the pension account is the same, and only changes is the gender. Each color represents refers to one of the gender, which I don't know which is which. As we can see, there is no difference at all. Even I would imagine, I think, yeah, like it doesn't look like there is a difference at all big, because the different gender has the same distribution, almost the same distribution in this case. Then I start to look at, like, I'm just choosing them randomly to see what's their relationship. Now I'm looking at, okay, the income, like the income with the current account, what it looks like. This is what it plots like. With the gender, with the current account, whether they are opening a current account or whether they are having a household income. Like, look at the scale. It goes from 0 to 25 million. That's way too much. This is income per year per household. So in this case, we know that the data is not distributed evenly. So we can change that into log plot. So on the y-axis, I'm making into log. And I do not see significant difference in this box plot. So something I would look for is like, okay, with this household income, if they have a lot of income, where would they put it to? Maybe a saving account? Yeah, then I'm looking at the saving account. For the first 100,000 people, none of them open up a saving account. Like, it's even less than the pension account, which is pretty bizarre to me, actually. So something to like something was to dig into, maybe the next 100,000 people would actually open up a saving account, or maybe saving account is not very popular in Santander. Then I start to look at, like, just keep exploring. I start to look at, okay, maybe, oh, is that household? So household income, current saving account. So, okay, payroll accounts. Now I'm looking at the payroll accounts associated with the household income. Like, still there isn't much difference within this. And I keep, I'm just exploring this randomly. You can choose something you like to explore. I would recommend choosing one specific account, and because that's one output, and then explore almost every input we have, like the household income or the age or the gender, something like that. And yeah, and funds. So from the funds, something like that, something interesting, I would say, like, as you could notice that people who owns over $1 million per year, they don't actually have funds. They don't have funds income. If they are earning less than, let's say, 50K, if they are earning less than 50K, they don't open up funds either. So that's a very interesting thing to see. So that ruled out like a large amount of customers who would like to open an account. There are so many things like
Here's how I design a 30-minute problem-solving workshop for 7 people. First step
So,
is to get instructions.
another thing is, like, I'm also testing this thing called the customer seniority compare with household income. So what we are having currently is that before we have a gender, we have the gender, and what else? When we have different colors, like we have a category of maybe 2 or maybe 5. But here I'm comparing two things. I'm comparing customer seniority, which is actually a value between 0, supposed to be 60. I think this 160 is quite bizarre. So customer seniority is kind of like how many years, I think how many years or how many months has the customer joined the bank. So I can't remember if it's month or year, but this 160 is definitely outlier. So when we see something like this with an outlier, that is something we would consider to exclude that from the whole training process, because this is something which is so bizarre that will mess up the algorithm. In this case, if you see something like that, exclude that, delete that from your data. That is part of the process in basically data preparation or data processing. And now when I'm comparing this, I'm using a scatter plot. The scatter plot, these lines, as you can see, which we know that they are definitely integer, because they only, like, they don't have anything between these two values, these two lines. So that's definitely an integer. So in this case, we can see these two are quite scattered, seem like the blue and the yellow are kind of averaged out. And here, the blue says this person doesn't own a credit card, and yellow means this person owns a credit card. So from here, what I'm observing is that it doesn't really matter household income, what kind of household income they have. They kind of, it's scattered like quite evenly in this plot. But something we might notice that is if the customer seniority is less than 10, they probably don't have a credit card. And if they're like below 60, well, they don't have a below 60, above 60. So if they are below 10, they might not have a credit card. But that also need to be double checked with all the data set, because I'm plotting 100,000. So these are the examples about how do we observe all these features, their relationship with the output we want to achieve. And then in this case, I'm saying something like with credit card or with pension, which I find really interesting that the new customer doesn't actually have a pension account. So I'm thinking maybe I can use the decision tree. So what is the decision tree? Decision tree makes a decision about, okay, if it's not a new customer, no, if it is a new customer, they won't actually create a pension account. Or if the age is below 20, they won't create a pension account. So decision tree is something like, okay, I'm making decisions in each step. I'm making first decision, and after I make a decision, I'm making a second decision, third decision. So this is what decision tree does. And from this, I think, oh, maybe I should use the decision tree. Or I could use something else, like when we're dealing with, because these are categories, like data. So if we're dealing with something more like scattered data, which I do not know what is happening. I can't see the relationship between these scattered points. What I could, and also because they are kind of continuous number, what I could do is I can start to create maybe I don't know, like principal component analysis, like, or calculating something called k-nearest neighbor. There are so many algorithms we can explore later, like not in this session. I do not want to jump into all these things and get you excited, and then we do not actually process the data properly. So yeah, I think I should stop talking and leave everything to you, because I talked too much examples. And
Sorry,
I'll leave the...
sorry.
Yes.
There are questions here.
Yes.
And Ellen asking to repeat the title of the book on data visualization.
And very simple title is called Data Visualization. Yeah, it's called Data Visualization, A Practical Introduction. This, I like reading books, so I got this book. Also, the package we're using called Plotly. Plotly here, it is a Python package. It has a lot of nice figures on the examples documents as well. So if you want to, like if you like prefer to read online and you don't want to buy a book, you can explore their documents. They have loads of plots, and maybe you could get some inspiration from them as well. Okay, now I'm going to leave this to you, and we're
There's
just going
another
to...
question.
Oh yeah.
Can I read it? Sorry.
Yes. Yeah, I'm also going to.
May I know if you go? May I know if you will go through the Python code, or maybe give some sample code for us to refer to? As I have knowledge of Python, but I have not used the data analysis package before. Yes, that's all. So,
Yeah, so this is just some example I generated basically yesterday. So I don't think you need this code. What I can show you is I can show you the example code, like basically that's it. Everything else is a variation, changing the x, changing the y, maybe changing the box plot into scatter plot. So yeah, if you have technical questions regarding to this, we can answer them. But I can also share it after this session. Then you can use it as a template to continue exploring the data analysis of it as well.
Have you mentioned if they put them in the machine learning channel that will answer as well for you?
Oh, yes, yes. I think so. So in the Slack channel, if you have any questions and none of us had time to look at it, you can also post it on the machine learning Slack channel, and some of you guys would answer it as well.
I'll be checking for sure.
Yeah. We're gonna have a look. Okay. Any other questions? Oh, okay. I'll leave the ground to you guys, and if you have any questions, feel free to ask.
And we have cupcakes at back if you feel like it. Should I stop recording it? It's fine. Just the O. Just Spanish.